5.0, we are live. Okay, so we've already done a lot of these probabilities where they're independent. What's the probability of getting ahead and a 3? And so we would symbolize this as probability of getting ahead. So if I'm tossing a fair coin and throwing a dice in that order, what's the probability of getting ahead and a 3? Well, we know from the multiplication principle that this is just probability of throwing ahead times the probability of throwing a 3, because this dice does not have any influence on that toss. Okay, so we could also express this another way, which is the probability of getting ahead and a 3 based on the probability of getting ahead times the probability of throwing a 3, given that I've already tossed ahead, okay? And so this probability is 1/2 times 1/6, which is equal to 1/12. So if I'm playing this exciting toss the coin, throw the dice game, probability of that outcome is 1 in 12. And since the events are independent, even though I'm symbolizing it this way, probability of getting ahead is 1/2, and the probability of getting a 3, given that I've already thrown ahead, is also just 1 in 6 because they are independent. But we are going to look at the situation where this second event, the probability changes given the outcome of the first event. Okay, and that's where the conditional part comes in. So that's nice, just a nice introduction to the symbols that we're going to be looking at. This means the probability of throwing a 3, given that I've already tossed ahead. And this is the independent case where the outcome of the first event doesn't influence the outcome of the second event. All right, now we're going to go to the example where we're drawing some cards out of a group of cards, okay? So here we go. What's the probability of drawing 2 clubs? Or sorry, 2 spades in this case, because I was too lazy to pull the clubs out of this group of cards. Okay, so what's the probability of drawing 2 spades? And I need to modify this a little bit because I don't want to have an even number of spades and diamonds, because that would just be a bad example. Here I have to pull out my giant cards, and I'll find another diamond. And all of these are hearts. In fact, right now, oh, there we go. There's a diamond. Okay. All right. Okay, so we've unevened those just to make it a little bit more obvious. So what's the probability of drawing 2 spades? And so we're going to symbolize this. What's the probability of the first card being a spade and the second card being a spade? Okay, so I have 8 cards altogether. 3 of them are spades. 5 of them are diamonds. Okay. And so in the first place, I just know this is going to be the probability of drawing a spade. So that's easy, right? What's the probability of getting a spade for my first card? So I've got 8 cards. 3 of them are spades. Anybody out there in internet land want to take a shot at the probability of drawing the first card as a spade?
Three out of 8.
3 over 8. That's right. 3/8. There's a 3/8 probability of drawing a spade the first time. So there we go. I've drawn a spade. Okay. Now, the second stage of this, what's the probability of drawing a spade in my second draw, given that I've already drawn a spade? Okay. So the fact that I've actually changed this, there are only 7 cards left and only 2 of them are spades. This second probability has changed. And so what's the probability of the second card being a spade, given that the first card was a spade? Anybody in the internet land?
2/7.
2/7. That's right. Not 2 out of 7, because that would be odds. So there we go. Okay. So 3 out of 8 the first time. 3 over 8 the first time. 2/7. And so as you can see, we have 6 over 56 is the probability of drawing 2 spades. Now, you could look at this a second way, because we did talk about probability and counting. So we could actually say, what's the probability of drawing 2 spades in this case? And if you recall, before we were doing this whole thing where we go, well, I have 3 spades. How many combinations of 2 of them can I get? And this is going to be out of the total number of combinations of 2 cards. If I'm drawing from a group of 8, 3 choose 2 is 3, and 8 choose 2 is 8 times 7 over 2 times 1, which is equal to 3 over 28. And if I reduce this, this is just 3 over 28. All right. So the probability of 2 events happening, if they are not independent, in other words, if they're dependent event, is the probability of the first event times the probability of the second event, given that the first event has happened. Okay? All right. Now we can do what we want. We can rearrange this formula and we can make it seem like a little bit mysterious. So we could actually divide both sides by the probability of the second event given the first event, and we'll see what the implications of that. Oh, look at that. That should be a 2 there, but everybody in internet land's probably figured that out already. Okay. So we can actually just say the probability of the 2 events happening divided by the probability that the second event happens given that the first event happened is actually equal to the probability of the first event or the first condition. So we can rearrange this whole formula. And we can come up with some surprising conclusions. Okay, so for example, 20% of Ford vehicles are trucks. Okay, some year 20% are trucks. And 5% of the vehicles on the road are Ford trucks. So you're driving down the road, 5% of the vehicles that you come across are Fords and they're trucks. And 20% of Ford vehicles are trucks. And so if it's a Ford, given that it's a Ford, probability that it's a truck is 20%. Does that make sense so far? Okay. So the probability that it's a Ford and it's a truck divided by the probability that it's a truck given that it's a Ford is actually going to tell me the probability that any vehicle on the road is a Ford. Okay. So in other words, this can be rewritten as 0.05 divided by 0.20 is equal to 0.25. Sorry, 0.25. So in other words, 25% of the vehicles on the road are Fords. Now, keep in mind that I have completely fabricated all of these statistics, and so if you say, that's not right, there's not that many Ford trucks out there, you would be right. I made this up completely. But you can see how this can work to help you draw some surprising conclusions about probability of something happening